This video covers some practice work for number operations. It is intended to go with the instructional video on number operations, but you can use this for practice regardless of whether you have watched the other video. Pause the video here and work these problems on your own, then unpause the video and check your answers. These first two questions are intended to be vocabulary questions more than they are arithmetic questions. Now, of course, they do also assess your ability to carry out the operation, but the intent of these particular questions is to see whether you know what the word product and what the word sum mean. So product is the answer to a multiplication problem. So what is the product of 5 and 6? You would write down 5 times 6 and 30. Okay. And again, try to remember to write the answer below, not stringing it out from left to right. Sum is the result of an addition problem. So for number 2, you would write 5 plus 6 and then write down 11. It is also good form to make sure that you're writing down the 5 plus 6 and the 5 times 6, not just the numbers 11 and 30. That lets your teacher or whoever's assessing your work, let them know where you got it from and what operation you did to get there. Now, that might seem a little bit self-evident on a problem that's this simple, but as problems become more and more complicated, it's not as self-evident, and you want to be in the habit of doing it. The third and fourth problems are just straight operation problems. So we have 11 minus 7. 11 minus 7 is 4. And the next one is 35 divided by 5, which is 7. These next two problems are more complicated because they are multi-step problems, and they require you to look at the grouping symbols to see what order things should be done in. So inside my parentheses here, I do have a 2 plus 3 times 4. Now, we didn't really cover it in this video, but most of you are probably familiar with your order of operations, and the acronym for that is PEMDAS. And that stands for parentheses. Now, I always tell my students it's not just parentheses, it's any grouping symbol. Just the P is convenient because the parentheses are the most common grouping symbol that we have. But you have your grouping symbols, then you would do your exponents. We have not at this point introduced any exponents. And then we have multiplication and division going from left to right. So M and D go together, and there is a good reason for that. And then we have addition and subtraction also from left to right. And you'll notice that I separated those with a slash, indicating that they actually have the same level in order of operations. You do go from left to right with those. So looking at our first problem here, we do have a grouping symbol right here with the brackets. And so we're going to start inside the brackets. Inside the brackets, we have adding, and we also have that implied multiplication right there where I just highlighted. In our order of operations, multiplication comes before we do addition. So the first thing we do on this particular problem is the multiplication. So we will have 2 plus 3 times 4 is 12. And then divided by 7. Notice that I copied everything down that I wasn't using. So I still wrote 2 plus. I didn't do this scratch work, just that like I have a 12 floating in there, and I still copied down the divided by 7, even though I'm not doing anything with that. Now we'll go ahead and do what's in the brackets because that's grouped together. So 2 plus 12 is 14. And once I do that, I no longer need the grouping symbol. That leaves us with 14 divided by 7, which is 2. On the next problem, again, we do have a grouping symbol with the parentheses. So normally we would do multiplication first, but because we have this grouping symbol here, we are going to do the addition first. So we'll start with 1 plus 6. Now, again, depending on how much math you've had and when you're watching this video, you might be thinking, well, couldn't I do distribution? Yes, you could. But at this point, this video doesn't cover that. So we're going to go straight with the order of operations there. And we'll start with the 1 plus 6, which is 7. And now we have 8 times 7, which is 56. And 56 plus 3, which is 50. Again, notice my top-down structure to my work. I am not stringing out stuff all in this space over here. If you wanted to know where the 7 came from, where you're going to look to see where the 7 came from is right above it. It always surprises me how many students don't do that or don't realize that their work should be organized in a way to show that. So I really want to emphasize that. All right, now the next 4 questions are all about a particular property of the different operations that we have. And you'll notice it's the same question, just we have adding, subtracting, multiplying, and dividing. So the question is, does it matter what order we add numbers in? So to do this, I'm going to give you some examples. So suppose I have 3 plus 4, and then I switch the order and have 4 plus 3. Well, in both of those cases, the answer would be 7. Now you might be thinking, okay, well, for those it worked. Will that work all of the time? So we'll pick another example. Let's do 1 plus 9 and then 9 plus 1. 1 plus 9 is 10 and 9 plus 1 is also 10. And we could do one more example. We could say, I don't know, 8 plus 5 and 5 plus 8. And in both of those cases, we get the number 13. So the answer to that question is no. This does not constitute what's called a proof in math, but it is enough to be convincing that it doesn't matter what order we add the numbers in. We are free to switch the order of the numbers however we want. So the follow-up question to that is, does it matter what order we subtract numbers in? So if I have, say, 10 minus 3, is that the same thing as 3 minus 10? Well, 10 minus 3 is 7. 3 minus 10, depending on how much math you have, is either negative 7 or it is not doable. So if you're coming out of middle school, you might just say, well, you can't do that. If I only have 3 of something, I can't take away 10. And I've had students answer 0 because you would get rid of the 3 and you can't have less than nothing of something. The important thing to note here is that whatever that answer is, it is not 7. And so it actually does matter what order you subtract things in, because you don't get the same order, same answer each time. So with adding, you can just go ahead and change the order of your adding whenever you want, whatever is going to look better, whatever is more convenient. But if it's subtracting, no, you cannot. You cannot just change the order of your subtraction. And then the last 2 problems do the same thing except with multiplication and with division. So if I pick 2 numbers and say do 7 times 6 and then do 6 times 7, I get 42 each time. And there's some pretty neat ways to reason that out. One way that I like to do it is using the area of a rectangle. If I have a rectangle and one side length is 6 and the other side length is 7, the area will be 42 no matter what. And it doesn't matter if you turn the rectangle on its side and you say, okay, it's 6 times 7 or 7 times 6, like the area or the space size of that rectangle is going to be the same no matter what. You can do that just like we did with the addition. You can do that with as many pairs of numbers as you want. Now let's take a look at division. If I have 2 divided by 1, is that the same as 1 divided by 2? And if you've had elementary school math, you can go ahead and do that. You can do that out the long way. 2 divided by 1 is 2, but 1 divided by 2 is 0.5 or 1/2. And in fact, if you think of that 1/2, that fraction bar does function as a division symbol. And so these are not the same. So with multiplying, does it matter what order you multiply them in? No. And that's really, really powerful later on. Does it matter what order we divide in? Absolutely, yes, it does. Now, this all is getting at something called the commutative property of addition and multiplication. We would say that adding and multiplying are commutative. Commutative means that the order that you do them in does not matter, but subtraction and division are not commutative, meaning that the order does matter. Don't forget to like and subscribe if you found this video helpful, and I'll see you in the next one.